Today we are going to learn about deploying ML models with FastAPI. You will gain skills in creating a FastAPI application to efficiently serve pre-trained machine learning models.
Welcome to our session on deploying machine learning models with FastAPI. In today's video, we'll explore how FastAPI, a modern and fast web framework for building APIs with Python, can be used to efficiently serve your machine learning models. FastAPI is known for its high performance, ease of use, and its ability to handle asynchronous requests, which makes it an excellent choice for deployment. By the end of this session, you will have learned how to set up a FastAPI project, load and prepare a pre-trained model, create API endpoints for model inference, and integrate FastAPI with Docker. Let's dive in and start building scalable and efficient ML model deployments. FastAPI is a modern web framework written in Python that is quickly gaining traction due to its high performance, ease of use, and ability to handle asynchronous requests. One of the most significant benefits of FastAPI is its speed, which comes from its use of asynchronous programming. Asynchronous operations allow the server to handle many requests simultaneously, making it a great choice for applications that require high throughput, such as ML model serving. FastAPI automatically generates interactive API documentation using OpenAPI and JSON schema. This feature is particularly useful for developers and users who want to test the API endpoints quickly without writing additional documentation. FastAPI's ability to integrate seamlessly with machine learning models makes it a preferred choice for data scientists and developers who need to deploy models efficiently. Its native support for data validation and serialization further simplifies the process of developing robust APIs. To get started with FastAPI, you'll first need to set up a project. Begin by creating a new directory for your project and navigating into it. It's recommended to use a virtual environment to manage dependencies. You can create one using Python and mvenvend and activate it. Next, you'll need to install FastAPI and Unicorn, a lightning-fast ASCII server for serving FastAPI applications. You can do this by running pip install FastAPI Unicorn. Once installed, you can create a basic FastAPI application by creating a file, say main.py, and adding a simple FastAPI app instance with a root endpoint. Here's a quick example: Python from FastAPI import FastAPI app equals FastAPI at app.get/async def root, return, message, hello world. Now, you can start the FastAPI server by running Unicorn main app reload. The reload flag allows the server to automatically reload whenever you make changes to your code. With this setup, you have a basic FastAPI project ready to be expanded upon for deploying ML models.
With your FastAPI project set up, the next step is to load and prepare the pre-trained machine learning model you intend to deploy. Depending on the model, you may need to install additional libraries such as TensorFlow, PyTorch, or scikit-learn. Once installed, you can load your model within the FastAPI application. For instance, if you're using a model from scikit-learn, you can use the joblib library to load a pre-saved model file. Here's an example: Python import joblib model equals joblib.loadModel.pkl. After loading the model, consider how your API will need to prepare input data for inference. This may involve data preprocessing steps to ensure that the input format matches what the model expects. It's also important to consider any dependencies your model may have, such as specific data transformations or external data sources. Incorporating these elements into your FastAPI application will ensure that your model makes accurate predictions. Lastly, think about error handling and validation, ensuring the API can gracefully handle invalid inputs or unexpected model behavior. Creating API endpoints for model inference is a crucial step in deploying your machine learning model with FastAPI. Begin by defining the endpoints in your FastAPI application where clients can send requests for predictions. A common practice is to use POST requests for inference, allowing clients to submit data in the request body. In your endpoint function, integrate the model's prediction logic by receiving input data, processing it as required, and then using the loaded model to make predictions. For example, Python from pedantic import base model class input data base model, feature 1, float feature 2, float at app.post/predict async def predict data, input data equals data.feature1, data.feature2, prediction equals model.predict input underscore data, return, prediction.toList. In this example, we define a pedantic model input data to validate the input data structure. The /predict endpoint receives JSON input, processes it, and returns the model's prediction as a JSON response. Input validation is critical to ensure that data sent to the model is in the expected format, reducing the risk of errors during inference. By structuring your API endpoints thoughtfully, you ensure that your FastAPI application is robust and ready to serve predictions efficiently. One of FastAPI's standout features is its ability to handle asynchronous requests, which can significantly improve the performance of your model serving application. Asynchronous programming allows your server to handle multiple requests concurrently, making the application more responsive and capable of managing higher loads. To leverage this capability, use the async and await keywords in your endpoint functions. This ensures that long-running operations, like model inference, do not block the execution of other requests. For instance, if your model inference involves accessing remote data or performing time-consuming computations, using asynchronous functions allows other requests to be processed simultaneously. Here's an example of how you might use async functions in a FastAPI app. Python at app.post/async_predict, async def async_predict data, input data, simulate a time-consuming operation await asyncio.sleep2 input_data equals, data.feature1, data.feature2, prediction equals model.predict input_data, return, prediction.toList. In this example, await asyncio.sleep2 is used to simulate a delay, demonstrating how asynchronous operations can be incorporated. Asynchronous handling is particularly beneficial when deploying models that need to manage many simultaneous prediction requests, as it helps optimize resource usage and reduces response times.
Deploying your FastAPI application with Docker provides a consistent environment for running your machine learning models, regardless of the underlying infrastructure. Docker allows you to package your application along with all its dependencies into a single container, ensuring that it runs the same way on any system that supports Docker. To begin, you'll need to create a Docker file in your project's root directory. This file contains the instructions for building your Docker image. Here's a simple example of a Docker file for a FastAPI application. Docker file from Python 3.8 workdir/app copy /app run pip install no cache dir or requirements.txt.cmd unicorn main app host 0.0.0.0 port 80. In this Docker file, we start with a Python 3.8 base image, set the working directory, copy the application code, install the necessary Python packages, and finally, specify the command to run the FastAPI application using unicorn. Once your Docker file is ready, you can build your Docker image by running docker build t my FastAPI app. And then start the container with docker run p8080 my FastAPI app. Using Docker not only simplifies deployment but also enhances the scalability and portability of your FastAPI applications, making it easier to manage and scale in production environments. Testing your FastAPI application is an essential step to ensure that it functions correctly and meets user expectations. Thorough testing helps identify and resolve issues before deploying the application to production, improving reliability and user satisfaction. Start by manually testing your API endpoints using tools like Postman or curl. These tools allow you to send requests to your application and verify the responses, ensuring that the endpoints are correctly processing input data and returning expected results. For example, you can use Postman to send a post request to the /predict endpoint with sample input data and check if the predicted output is accurate and formatted as expected. Beyond manual testing, consider writing automated tests to validate your application's core functionalities. Automated tests can be implemented using testing frameworks like PyTest, enabling you to run a suite of tests that cover various scenarios, such as valid and invalid inputs, edge cases, and error handling. Additionally, it's crucial to test the accuracy of your model's predictions to ensure that the deployed application performs as intended. You can create test cases that compare the model's predictions against known expected outcomes to verify its accuracy. By conducting comprehensive testing, you ensure that your FastAPI application is robust, reliable, and ready for deployment. Deploying your FastAPI application securely and ensuring it can scale effectively is critical for maintaining a reliable and trustworthy service. Start by implementing HTTPS to encrypt data in transit, protecting it from potential eavesdropping or tampering. This is a fundamental step for any application exposed to the internet. Additionally, consider implementing authentication and authorization mechanisms to control access to your API endpoints. FastAPI offers integrations with OAuth2 and JWT, which can be used to secure your application and protect against unauthorized access. To ensure scalability, monitor your application's performance and resource usage. Tools like Prometheus and Grafana can be integrated to collect metrics on request latency, throughput, and error rates. This data can help you identify bottlenecks and optimize your application for better performance. Scaling can also be achieved through load balancing and distributing the application across multiple servers or containers, allowing it to handle increased traffic efficiently. Another best practice is to regularly update your application's dependencies to ensure you're using the latest security patches and performance enhancements. This reduces the risk of vulnerabilities and keeps your application running smoothly. By following these best practices, you can deploy your FastAPI application securely and ensure it is prepared to scale with demand.
In conclusion, we've explored how FastAPI can be an effective solution for deploying machine learning models, thanks to its speed, ease of use, and asynchronous capabilities. We covered the steps to set up a FastAPI project, load and prepare a pre-trained model, and create endpoints for model inference. Additionally, we discussed integrating FastAPI with Docker to streamline deployment and applying best practices to ensure secure and scalable deployments. By leveraging these tools and techniques, you can efficiently serve your machine learning models and meet the demands of modern applications. Thank you for watching, and we hope you found this session informative and helpful in your journey to deploying ML models with FastAPI.